This is SpaceTime, Series 27, Episode 125, for broadcast on the 16th of October 2024. Coming up on SpaceTime, discovery of the most distant spiral galaxy ever seen, a record-breaking recovery of rocks that originated deep inside the Earth's mantle, and the European Space Agency's Hera asteroid mission launches from Cape Canaveral. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered the most distant spiral galaxy ever seen. The galaxy, catalogued as Rebels 25, seems to be every bit as orderly as present-day spiral galaxies. But it's being observed some 13.1 billion years ago. That's a time when the universe was only 700 million years old. The findings, reported in the monthly notice of the Royal Astronomical Society, are surprising. That's because, according to science's current understanding of galactic formation, such early galaxies are expected to appear far more chaotic. The rotation and structure of Rebels 25 were revealed using ALMA, the Atacama Large Millimeter Submillimeter Array Radio Telescope in Chile's Atacama Desert. One of the study's authors, Jacqueline Hodge from Leiden University, says the galaxies we see today have come a long way from their chaotic, clumpy counterparts which astronomers typically observe in the early universe. Scientists expect most early galaxies to be small and messy-looking. These messy early galaxies then merge with each other, and then gradually, over billions of years, they evolve into smoother shapes. Current theories suggest that for a galaxy to be as orderly as, well, say, our own spiral galaxy, the Milky Way, a rotating disk with tidy structures like elegant sweeping spiral arms, billions of years of evolution must have elapsed. However, the detection of Rebels 25 challenges that timescale. Rebels 25 was initially detected in a previous observation by the same team, also using ALMA. At the time, it was already considered an exciting discovery, showing hints of rotation. But the resolution of the data wasn't fine enough to be sure. So, to properly discern the structure and motion of the galaxy, the authors performed follow-up observations at higher resolutions, and that confirmed its record-breaking nature. Surprisingly, the data also hinted at more developed features similar to those in the Milky Way, like a central elongated bar, although more observations will be needed to confirm this. The bottom line is, these new observations of Rebels 25 are transforming science's understanding of early galaxy formation, and consequently, the evolution of the universe as a whole. This is SpaceTime. Still to come, the record-breaking recovery of rocks that originated in the Earth's mantle, and the European Space Agency's Hera asteroid mission finally launches from Cape Canaveral. All that and more still to come on SpaceTime. Scientists have recovered the first ever long section of rocks that originated in the Earth's mantle. The mantle is the layer below the crust and the planet's largest component, making up about 80% of the Earth's volume. The retrieval of these new rocks will help unravel the mantle's role in the origins of life on Earth, how it drives global cycles of important elements such as carbon and hydrogen, and how volcanic activity is generated when parts of the mantle melt. The nearly continuous 1,268 metres of mantle rock were recovered from what's called a tectonic window. That's a section of seabed where rocks from the mantle were exposed along the Atlantic's mid-ocean ridge. The expedition was undertaken by the ocean drilling vessel Geordie's Resolution last year. With attempts dating all the way back to the early 1960s, this recovery was a record-breaking achievement, led by the International Oceans Discovery Program, a marine research consortium involving more than 20 countries that retrieves cores, cylindrical samples of sediment and rock from the ocean floor in order to study Earth's history. Since its successful collection, the expedition's been compiling an inventory of the recovered mantle rocks in order to better understand their composition, structure and context. And their findings, reported in the journal Science, are revealing a more extensive history of melting in the recovered rocks than what was expected. The The study's lead author, Johan Leisenberg from Cardiff University, says this recovery is a major achievement in the history of Earth sciences. But more than that, its value is in what the cause of mantle rocks tells us about the makeup and evolution of our planet. The study begins to look at the composition of the mantle by documenting the mineralogy of the recovered rocks, as well as their chemical makeup. And the results differ from what was expected. There's a lot less of the mineral pyroxene in the rocks than what was thought there would be, and the rocks also have far higher concentrations than expected of magnesium. Now, both of these are the results of higher levels of melting than what had been previously predicted. This melting occurs as the mantle rises from deeper parts of the Earth towards the surface. As it moves up to the surface, pressure is relieved and the solid mantle starts to liquefy. The results from further analysis of this process will have major implications for understanding how magma is formed and how that leads to volcanism. The authors also found channels through which the melt was transported through the mantle, and so they were able to track the fate of magma after it formed and travelled upwards towards the surface. This is important because it tells science how the mantle melts and feeds volcanoes, especially those on the ocean floor, which accounts for the majority of volcanism on Earth. Having access to these mantle rocks will now allow scientists to make the connection between volcanoes and the ultimate source of their magmas. The study also provides initial results on how olivine, an abundant mineral in mantle rocks, reacts with seawater, leading to a series of chemical reactions that end up producing hydrogen and other molecules which can fuel life. In fact, scientists believe that this might have been one of the underpinning processes which resulted in the origins of life on Earth. Rocks that were present early on Earth bear a closer resemblance to those retrieved during this expedition than the more common rocks that make up the continents today. So, analysing them gives scientists a crucial view of the chemical and physical environments that would have been present early in Earth's history, and that could have provided a consistent source of fuel and favourable conditions over geologically long timescales to have hosted the very earliest forms of life. And that's worth thinking about. This is SpaceTime. Still to come, Europe's Hera asteroid mission launches into space, and later in the science report, a new highly transmissible version of COVID-19 has arrived in Australia. All that and more still to come on SpaceTime. SpaceX have managed to sneak in the launch of the European Space Agency's Hera asteroid inspection mission just hours before the Milton the Monster Show hurricane slammed into Florida. However, while they were able to get Hera off into space, they were forced to scrub plans to also launch NASA's Europa Clipper mission to the Jovian ice moon because of the approaching Category 5 tropical cyclone. SpaceX got the approval to launch the Falcon 9, which had been granted since late September's Crew 9 mission to the International Space Station because of an issue with the Falcon 9's upper stage missing its intended re-entry target. The FAA approved the Hera mission as its launch wasn't going to feature a second stage re-entry. The mission was flown from Space Launch Complex 40 at the Cape Canaveral Space Force Station just a day before Milton began to make its presence felt along the Gulf Coast. It was also the 23rd and final launch for the same first-stage booster, which needed to use up all its fuel in order to place Hera into its interplanetary transfer orbit.
All systems are go. Let's listen in to terminal count.
LD, go for launch.
Falcon 9 transports the European Space Agency's Hera spacecraft into space.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Engines full power, and liftoff. Go Hera, go Falcon, go SpaceX.
Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Slick 40. After clearing the tower, we begin to tilt or gimbal the engines. That initiates a roll maneuver. This enables the vehicle's antennas to stay in the best position for communicating with the ground. We are into throttle down now in preparation for max dynamic aero.
Falcon is supersonic.
Faster than a speeding bullet, we're supersonic on Falcon 9. Waiting for the call out from GNC of max Q.
Max Q.
Right on time. We're through the period of maximum pressure on the vehicle. The Merlin engines are back at power, and we're out of the throttle bucket. Now, from here on, even though the velocity is rapidly increasing, the atmospheric density is decreasing, and that's resulting on less loads on the Falcon 9. 90 seconds into flight, the rocket typically needs to go 17,500 miles per hour horizontally in order to avoid gravity pulling it back down to Earth and getting into orbit. We've heard the call out for MVAC chill. That's a bleed valve on the second stage engine. That's performing the final chill prior to second stage engine ignition. All's looking good with the first stage trajectory. We're coming up on T plus 2 minutes. Now we've got 3 events that'll be coming up in just under 30 seconds. Main engine cutoff. The 9 Merlin engines will be throttled down and shut down. Then we'll get stage separation and then startup of the MVAC engine on its first of 2 burns on the second stage. We've begun throttling down the Merlin engines.
Main engine cutoff.
Call for MECO.
Stage separation.
Successful stage separation.
MVAC ignition.
MVAC ignition and warp on power on stage 2. Coming up will be fairing deployment. And for the first stage, farewell 1061, and we thank you. As we continue climbing out of Earth's atmosphere.
Fairing separation.
And successful payload fairing separation. As we mentioned earlier, the fairing halves have supported multiple missions. One half has flown 12, now 13 missions, and the other had previously flown 18. And those fairing halves will come back down to Earth. They're guided by cold gas thrusters and then parachutes or parafoils.
Falcon is on a nominal trajectory.
They'll deploy, and they'll be recovered by our recovery vessel, Doug. Jesse, T plus 4 minutes, 23 seconds. Everything continues to look good on Falcon 9 with Hera.
A 1,128-kilogram Hera spacecraft is now on a 2-year journey to the near-Earth asteroid Dimorphos and its tiny moon Didymos. Didymos was the target of NASA's DART double asteroid redirection test, which was designed to slam and impact a spacecraft into an asteroid to see whether it could be deflected onto a different trajectory. The DART spacecraft hit Didymos on September the 26th, 2022, altering its orbit around Dimorphos, shortening it by 32 minutes, and leaving a massive crater and debris cloud in its wake. The test marked the first time that humanity had demonstrated its ability to deflect an asteroid, thereby providing proof of concept that we just might be able to protect the Earth from potential asteroid impact by altering the asteroid's path. Of course, that's if we know about the asteroid early enough. Hera, together with its 2 CubeSats, Milani and Juventus, will undertake an extensive forensic evaluation of exactly what happened in the wake of the DART impact. The mission will help answer outstanding questions, such as the exact mass and composition of Dimorphos, the structural effects of the impact, the size of the crater formed by the collision, and analysis of the expanding debris cloud caused by the impact, and whether Dimorphos might actually have been fractured by the collision and is now only held together by weak gravity. The 2 CubeSats will help with the study and eventually land on the asteroid. This report from ESA TV.
2 years ago, NASA made history by intentionally slamming into an asteroid with its DART mission. The asteroid wasn't a threat to us here on Earth, but scientists wanted to see if they could change the path of an asteroid to test a technique that could one day protect us from a real threat. The experiment was a success. Humans can move an asteroid. But the bad news is that scientists aren't sure yet they understand why it worked. There is still a lot we don't know, like what exactly happened on the asteroid's surface after the impact, what the asteroid is made of, and how well the deflection worked. Hera spacecraft will fly to that same asteroid to answer all of our questions. Hera will perform a close-up crash scene investigation, gathering data on the asteroid's mass, structure, and makeup to turn this kinetic impact method of planetary defense into a well-understood and repeatable technique. Why do we need to protect our planet? In 1908, people reported a bright flash and a noise that sounded like a bomb. 10 minutes later, this was from the largest observed asteroid strike ever recorded, which occurred over the Tunguska region in Siberia. People up to 500 miles away reported seeing the flash. Some claimed it was even brighter than the sun. The explosion was massive, causing 80 million trees to flatten, windows up to 250 miles away to smash, and the effects of the shockwave could even be felt in London. This represented a lucky escape for Europe. It happened just a short distance from affecting heavily populated regions. As a result, ESA, NASA and other space agencies started closely monitoring space to track potentially dangerous asteroids. So far, we have found more than 35,000 asteroids whose orbits bring them dangerously close to Earth. But if one was on a collision course with us, what could we do? To answer this question, an international team came up with the first planetary defence mission: DART to hit the asteroid and Hera to gather data after the impact. Knowing there are so many asteroids that could be a danger to us, how did we pick one to explore? The asteroid that DART hit and that our Hera spacecraft will now visit is called Dimorphos. It's a small asteroid, about half the size of the Eiffel Tower, but if it impacted Earth, it could devastate a small country or city. Dimorphos orbits a larger asteroid called Didymos, which Hera will also visit. Together, the two asteroids form the Didymos system. Here are some of the reasons why scientists decided to explore the Didymos system among all the asteroids out there. The two asteroids are not a real threat to Earth, so nudging one of them wouldn't accidentally set it on a crash course to Earth. The system passes relatively close to Earth, so they are not impossible to get to. The 150-metre diameter of Dimorphos is important. We know about 95% of all near-Earth objects larger than 1 kilometre in size, but the majority of smaller asteroids are yet to be discovered, despite their city-killing potential. Since Dimorphos orbits Didymos, we can easily see any changes in its orbit from Earth. So, what are we expecting to see on Dimorphos? We asked one of our experts, Patrick Michel, the principal investigator of the Hera mission, to find out more.
So what we expect to find on Dimorphos? That's a big question. Actually, we don't really know, because the DART mission by NASA made an impact on Dimorphos, and based on the current data that we have from this mission, there are different solutions. So Dimorphos may host a crater whose size is unknown, or it could be completely reshaped.
Prior to DART's impact, it took Dimorphos 11 hours and 55 minutes to orbit its larger parent asteroid. Since the collision, astronomers have found that the spacecraft's impact altered Dimorphos' orbit around Didymos by 33 minutes, shortening the orbit to 11 hours and 22 minutes. The mission was deemed a large success, but to learn more about these asteroids' physical properties and DART's impact outcome, we need to visit them. Initially, we thought that when DART crashed into Dimorphos, it would create a big impact crater, potentially the first one ever made by humans. But now, scientists think there might not be a crater on Dimorphos after all. More recent simulations suggest the impact might have completely changed the asteroid's shape. Scientists estimate that around 8% of the asteroid's mass was shifted around its body, and 1% of the entire mass of Dimorphos was thrown into space, some of which may reach as Hera Earth as small meteoroids.
So the DART impact generated a lot of ejecta, a lot of material that is still escaping from the system at tens of thousands of kilometers from Dimorphos. And it may be that some small particles eventually reach Mars or the Earth, but in the form of shooting stars, like what you see in the sky during the night, so with no risk. We don't know what it looks like now, so there's going to be a lot of surprises, and I'm so excited because in 2 years we will have the answer.
Crater or no crater, we need to go back to Dimorphos to study the aftermath of the impact. This will help us turn the DART deflection experiment into a well-understood, repeatable technique that might one day be needed for real. So, we know it will take us 2 years to reach the asteroids after launch, but how do we get there? On its way, Hera will make a swing by of Mars in March 2025, borrowing speed to help reach its destination. In the process, Hera will get as close as 6,000 kilometres from the surface of the red planet, closer than the orbits of the two Martian moons. Hera's trajectory will be tweaked so that it can train its science instruments onto Mars' smaller moon Didymos for less than 1,000 kilometres away, a practice run for when it reaches the asteroid system, while also observing Mars itself. A second deep space manoeuvre in February 2026 will line Hera up for arrival at the Didymos system. Hera will have an impulsive rendezvous with the system in October 2026, meaning it will be captured by their gravity and begin to orbit. Didymos' gravity is estimated to be around 40,000 times weaker than Earth's, while Dimorphos' is approximately 200,000 times weaker. This is so low that Hera must orbit around their common centre of gravity at very low velocity to remain captured. To maintain the optimal distance for studying the asteroids, Hera's orbit will need regular adjustments, otherwise the spacecraft could gradually drift away from them. The possibility of Hera touching down on one of the poles of Didymos at the end of its mission is being considered. Although it has not been specifically designed for landing, it could descend towards the surface. However, on the surface, Hera will no longer be able to communicate with us on Earth, effectively bringing the mission to an end. What types of technology do we need to inspect an asteroid? Although Hera itself may not land on the asteroid, it is packed with new technologies which will allow us to study the asteroid in extraordinary detail. Hera carries a total of 12 instruments to explore the Didymos system. It has a state-of-the-art camera which will take detailed pictures of the asteroids, a laser altimeter which will create a map of the asteroid's surface, a camera which can look at the asteroids in different colours of light to find out exactly what they're made of, a radio science experiment which can use radio waves to figure out the mass and gravity of the asteroids. To explore Dimorphos and Didymos, Hera doesn't go by itself. Instead, the spacecraft carries two shoebox-sized CubeSats that resemble terrestrial drones, able to fly closer and take more risks and eventually even land.
And the reason why we bring these CubeSats is because we want to go at very close proximity of the asteroid, and we don't want to pose any risk to the main spacecraft. And these two CubeSats will contain their own instruments. And for the first time, for instance, we'll be able to probe the internal property of an asteroid, which has never been done so far. And that's on the Juventas CubeSat. On the second CubeSat, Milani, we'll measure the mineralogical composition of the asteroid and detect whether there is still dust around the body.
The two CubeSats, called Juventus and Milani, will get up close and personal with the asteroid. Juventus will use radar, sending out radio waves that will bounce off the asteroids and come back. By measuring how long it takes for the waves to return, we will be able to tell how far away the asteroid is at any given point and even what shape it is. More importantly, it will allow us to explore what an asteroid is like on the inside for the first time. Is Dimorphos a rubble pile or a monolith covered with pebbles and gravels? Once it has inspected both asteroids, it will then descend to Dimorphos' surface to take detailed pictures of the surface features, including hopefully the exact spot of the dart impact. Once on the ground, it will use a gravimeter to increase our knowledge of the gravity field of the asteroid. The other CubeSat, Milani, will measure the mineralogical composition of the asteroid and will analyse any surrounding dust. Later on, it will also attempt a landing on Dimorphos. Its onboard instruments will gather valuable data on the landing and any subsequent bounces to give insights into the surface properties of the asteroid. If Milani lands safely, its VISTA instruments will analyse the dust on Dimorphos' surface. By the end of the 6-month exploration by these 3 spacecraft, scientists will have a better understanding of the delicate art of asteroid deflection, and asteroid impacts will become the first avoidable natural disaster. At first glance, an asteroid is just a tiny dot of light in the sky. We require more observations to see if it is a real threat. Planetary defence is a global problem, and therefore we need to be able to work together with other space agencies to protect our planet, and Hera is the perfect demonstration of that.
However, as mentioned earlier, SpaceX's second scheduled launch of the week, NASA's Europa Clipper mission from the Kennedy Space Center's Launch Complex 39A, had to be scrubbed until Hurricane Milton had passed. The giant triple-core stage Falcon Heavy was safely secured inside SpaceX's hangar at 39A to ride out the storm. NASA have also delayed the planned return of Crew 8 aboard the SpaceX Crew Dragon Endeavour from the International Space Station because of Milton. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new highly transmissible variant of the COVID-19 virus has been detected in Australia. The new XEC strain has already been reported in 29 countries, including the United States, the United Kingdom and China. XEC is a recombinant COVID-19 variant. That means it's a mixture of two previous Omicron subvariants, KS1.1 and KP3.3, and it's resulted in a change in the virus's spike protein. That's made the disease more transmissible. The new strain is thought to have originated in Germany back in May. Last month, the World Health Organization classified XEC as a variant under monitoring, and the strain's already making between 5 and 10% of Australian COVID-19 cases. The World Health Organization says over 7 million people have now been killed by the COVID-19 coronavirus since it was first detected among workers at China's Wuhan Institute of Virology back in September 2019. However, the Lancet Medical Journal estimates the true death toll to be above 18 million, with some 780 million confirmed cases globally. The consumer advocacy group Choice has discovered that car manufacturers are not only spying on you when you're in your car, recording everything you do, but most of them are willfully passing that data onto government and law enforcement. The Choice investigation found most of Australia's popular makes of car collect and share data ranging from fuel usage to how you accelerate, how you apply your brakes, how fast you take corners, and just about every other aspect of your driving, even where you're going. Worse still, some are recording what you're saying in your car, who you're calling, who's calling you, the content of your smartphones, and even videoing what's going on inside the car. And it turns out it's not just your car that's spying on you. Even things like your robotic vacuum cleaner and other smart electronics at home, pretty well everything connected to the Internet of Things, is doing the same. It seems that manufacturers are collecting super intimate information about you, everything from your medical details and genetic information to your sex life, the sort of songs you like, and the sort of questions you ask Siri, Google or whatever. It's huge amounts of data, and it's all being used to make detailed profiles of you through inferences about things like your intelligence, your abilities, and your interests. And you can forget privacy and consent clauses, they're next to useless, meaning right now, without government legislation to stop it, there's absolutely nothing you can do about it. Well, it turns out deactivating your Facebook social media account really does increase your well-being. However, according to the new study reported in the Journal of the Royal Society Open Science, it also reduces your political knowledge. The findings are based on research involving 1,117 people who voluntarily deactivated their Facebook accounts during the 2022 French presidential elections. The authors surveyed the participants about their mood and well-being, political knowledge, and their level of political and social polarisation during the election. They then compared those results with a further 1,129 people who did not deactivate their accounts. They found that people who had deactivated their Facebook accounts reported having slightly higher well-being but lower political knowledge. However, they did find that people's level of political and social polarisation did not change despite deactivating their Facebook account. Chipmaker AMD have just released their new AI chips, setting new standards in the amount of calculations they can do. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
So AMD has been around for 50 years, as long as Intel, and they're the big competitor. Their chips are used in Tesla cars, they're powering the PlayStation and Xbox games consoles. And if you go into one of the regular stores, you'll see computers with the Intel inside chip and also the Ryzen chip, which is their version of the Intel chips that have been powering computers. And they are ahead of Intel with the AI built into the chip itself. So the measure of the speed of the neural processing unit, or NPU, which does all the AI grunt work, the minimum required for Microsoft's Copilot plus PC standard is 40 TOPS, or trillion operations per second. And Qualcomm, which makes the chips that go into most of the Android smartphones, their chip that runs Windows computers does 45 trillion operations per second. Intel is 48, but AMD is 50, and their high-end ones are 55 trillion operations per second. And this just means that the responsiveness when you ask your computer to do something AI-related, like compose text or rewrite it or create images or other things that AI allows you to do, it's just faster and more responsive. And look, in a few years, we'll be at 100 trillion operations per second and more. But AMD isn't just doing the chips for the laptops and desktops, but they're also doing chips for servers and for the data center. And the big company that most people know is NVIDIA. NVIDIA makes the H100 chip that is powering ChatGPT and Microsoft Copilot. But last year, AMD launched its what's known as the Instinct MI300X processor. That was their first one. And they committed at Computex, the big show in Taiwan, the tech show, that they would have an annual cadence of updates. And so they announced that the MI325X was coming this year. And the announcement happened at this conference that I'm at, where the MI325X will be available to the companies now and will be shipping in early 2025. And it's about 1.8 times faster than the H200 chip, the more advanced chip that NVIDIA launched earlier this year. So if you're looking at a computer, then have a look at the ones with the AMD Ryzen chip inside, because they're faster than Intel. They operate with lower power requirements. They generate less heat, and they're usually cheaper. So it's good to have competition and choice, and it pushes all the manufacturers, Qualcomm, Intel themselves, Apple, and Samsung, and everybody else to do better. And it's good to see competition happening in this space.
That's Alex Zaharov-Reutt from TechAdvice.life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.